Right, so for number 27, we want to solve this using approximation. So in this case, our x is already by itself. So in a normal situation, we would normally leave this the same, but they actually want us to figure this out. So remember, our goal whenever we see a log is to figure out what's the exponent on the base that gives me this. So let's try and think about this a little bit, and we'll just go through a bunch of them until we find the one that works out the best. So I know 3 to the first power is 3, that's too small. 3 to the second power is 9, still too small. 3 to the third power is 27, that's too big. I want it to equal 25. So my answer for my exponent has to be between 2 and 3. So now let's look at the multiple choices, which one's between 2 and 3, and the only possible answer is D. So since I know that that's the closest one, that must be the answer. So in 28, we see which equation is equivalent to this. So remember, there's two types of equations. We have logarithmic form, and we have exponential form. The quick way of doing exponential form without thinking is just really start with the base and go around. So this is just 2 to the x power is 1/3. Is that any of these here? And it looks like it's A. So that's the fast way of doing this one. For number 29, we have another properties of exponents, or properties of logarithms type problem. This time, instead of expanding, we have multiple logs. We're going to condense it into a single log. And if you remember, the shortcut way of doing this is we write the word log once, and we can just condense addition into multiplication and subtraction into division. So here we want to write log once, and let's just do all this math together. So we have 4 times 6 right here, because it's addition condensing to multiplication. Then I have a minus, so that's divided by 2. And so on top I get 24 over 2, which then this simplifies to just 12. So it's log base 5 of 12 is our answer. Now be very careful. One tricky one that a lot of people miss is they want to answer D. But one quick way we know that this is not true is when I'm condensing, how many times do we write the word log? We only write it once, but here we see, oh, there's log once here and twice. That's twice. We don't write it more than once when we condense, so this is not true. The only time we have a log over a log comes from an old base, right, if I'm doing a change of base. So in fact, this, if you notice, all of our problems are in base 5, but this is in base 10. That's because they changed it from from an old base. So this is not the correct answer. The last problem in this is a review problem to try and find the vertex. I already reminded you of that in an earlier video where when we did the quadratic formula we saw that the vertex formula is opposite b over 2a. So all we got to do is plug that stuff in. So my a is 1, it's that invisible 1 here. My b is 4 and my c is 3. So plugging those values in, I'm going to see that x is equal to opposite of b, which is negative 4, over 2 times 1. And by multiplying or dividing this out, I get negative 4 divided by 2 is negative 2. So automatically I know that b is wrong and d is wrong because my x value has to be negative 2. So how do we find the y now? Well, if we know the value of x, all we need to do is actually just plug it into the original equation. And that'll tell us our y. So if I do that, I get y is equal to x squared plus 4x plus 3. And we just substitute our value of x, which is negative 2. And so let's work this out. So I get negative 2 squared is going to be 4 minus 8 plus 3. And here I get 4 minus 8 is negative 4 plus 3 is negative 1. So my answer is negative 2 for x, and we got y is negative 1, which is A.